So finally, not finally because I'm on stage, but finally because we can show something live today, something we have been talking about for a couple of years. But first let me introduce you Chef Joris, who is with me on stage. Chef Joris is from Parabuild. Parabuild is a third-party application running on AutoCAD and BricsCAD.
I'll need to use it again in about a half hour, 45 minutes.
That provides tools for modeling of structural models, steel structures, also doing the detailing of the steel connections, providing the bill of materials out of the model, providing all the shop drawings, and also CNC automation. But this session is about, you have seen BIM now in the former session. This session is about the possibilities for third-party applications to integrate with our BIM solution. And for some of you, already explained yesterday in more detail. So our BIM solution also has an API. But what is the BIM API in our case? You have to realize this from a technical point of view. I think it's as straightforward as it can be. Because with us, BIM API is just all the standard DWG APIs that are available with some extensions. And then those extensions give access to our BIM-specific features, but that only represents maybe 1% of the total amount of functions compared to standard DWG APIs. And that's a bit because the design of our BIM solution, we don't use custom entities, we don't use complex things. We use as much as possible the native entities and entity types and things that are available in DWG. And in clever ways, the most clever ways we can think of, we add the BIM functionality and the features, which makes that the amount of functions that you need to access all those things like classifications, room data, the stories, the buildings, also for the structure elements that you have seen, the geometric information there, the profiles. It's all accessible with quite a limited amount of functions. And those functions are using exactly as much as possible the same syntax as you are familiar with in traditional DWG programming. So we would like to show you today a short, simple workflow, and we will start in BricsCAD. So hoping to see, yeah. So we start from an empty model. And what Jacob is going to do is, in this case, we are going to just import some geometry that represents a structure model, which could come from any other software, maybe even SolidWorks. But this is just pure dump geometry. Nothing is classified or anything. There's no data, just the geometry. And in the next step, what we can do is we can first BIMify the model so that our BIM will recognize where are the columns here in this model, where are the beams, what are the walls. So by this way, we already have a quick classification of where are the structural elements in the model. Now, in this case, we have no strength calculations, so in this case, for safety, we're going to increase the sizes of the columns and the beams, the sizes of the profiles. So that's being done now. We're applying standard HEA profiles in this case to the profiles, and With the walls, we just leave them like they are. They are classified. We don't need to do anything further, I think. So now this is a kind of conceptual model. And what we can do now is upload this model to Bricsys 24/7 and then pass it on to a structural engineer that is using Parabuild, for example. And we will now see what Parabuild can do with this model, also making use of the BIM API functions that we have available. So I can give the word to Rudy. I present you Rudy Joris, who is also from Parabuild.
Thank you, Luc.
Rudy, please.
So what we do is we detail the full structure and generate automatic output from that. So we don't want to start from zero, so we use the BIMified model. And we have an API to access all the BIM data. And we call this data LOD 200, level of development 200, because it is design stage. And we make LOD 400, fabrication stage, which means ready to be built. So since we have the API, you don't need to convert. You can just open it, the drawing, and we can just start modeling. It happens in the background. So we will draw some purlins using context modeling. This is a feature that uses the existing geometry in the drawing to get to your model faster. So we just say between columns, and we can get suggestions right under the cursor, and we just click to accept. So we draw a few of these. You can also set other limits like level height or alignments, rotations, etc. We do this for the beams as well. And after that, we want them connected as well. And connections in Parabuild are made using template drawings, constrained in template drawings. So the user can make his own connections as well. So what you do is you just say, I want a connection, you select the members, and the library is scanned, and it proposes valid connection choices. So you apply it, you make changes, and it adapts to this situation. Now you also, after you made your changes, you also want the rest connected. So we made a feature called Propagate, which finds similar locations in the model that we can apply the same connection to. So when you say propagate, you can see that the other side is also connected, the other purlins. We can do the same for the beams, which were not done here because it's considered different connections in beams and columns. So it's not restricted to these connections, propagate. We can also, now that these purlins are constrained to these existing beams, we can propagate these purlins, and we will find other places where we can apply the same purlins, also for the columns. And you can see that they are also connected and constrained everywhere, even in the back of the model. This will update when the model changes. So we'll also do this for base plates. It's the same thing. And after that, we will add some trusses as well, because the span of this building is too wide to support itself. We'll add some trusses for strength. This is also constrained in template drawings. So if we apply it here, it will adapt to this new size, this new location. So these have simple connections right now, welded connections, which we will remove and replace with something more complex, for which we will also use the library and find something with stiffeners. So you can see that these V-shapes, they're all a little different in angle. The higher it goes, the closer the V-shape. So this doesn't matter for propagate. It still recognizes the same situation. So if you propagate it, you see that the rest of the truss still gets these stiffener connections. So this truss is constrained using a dynamic array. And this dynamic array, this will keep these connections fixed when you change the number of entries. So if we reduce or increase the number of entries, these connections are relinked, some removed, some added maybe, and you can be rest assured that it stays updated. We can now, now that it's finished, also propagate this truss over the rest of the model. And all these connections, again, they follow, so they all get these new stiffeners. All right, so let's add a final detail, some more purlins in the bottom. And we do this so that we can add some bracings. So bracings are for rigidity of the structure. And you will get some, yeah, we will also propagate this over the model as well, so that these purlins are everywhere. So we can add a bracing, and you get, again, several connection choices to connect these bracings with their members. So we will try propagating this as well, but you know, it's clear that you normally do not need that many bracings. So you wouldn't do this now, the whole model has bracings, and you wouldn't really do that. So it's better to do this manually and just do them one by one. So propagate is just for repetitive, where you want them everywhere. So this is smart copy. It's basically like propagate, but you do it by yourself. So I think we're done modeling. We'll go back to the original LOD 200. So we can change the visibility back to LOD 200. They still exist. We didn't touch them. And they are linked. So if we now change, for example, the roof, and we move it upwards a little, then we can switch back to the, it takes a few seconds, to the LOD 400, and you can see that everything was updated, so all the trusses, purlins, etc., they came along, and the columns were increased in height. So let's quickly go to output. So this is the real goal of our application. So we want to generate 2D drawings, CNC files, bills of material, and we'll show these have 1,500 plates, but many of them are equal, so we have a numbering system. And this numbering system will give all equals the same number, so you don't get too many plates drawings. Here you see what you get. This is so the shop knows where to drill, how to cut, and how many to produce. So this is 1,500 plates, but only a few drawings. Let's show a few assembly drawings as well. This is so the shop knows where to weld and which positions to weld together. Okay, so the assembly drawing is generating. And you can see these all get dimensioning as well. These are automatic dimensions. They are placed using artificial intelligence, so to avoid collisions and that it turns out into a readable drawing without too much editing by the user. So let's show a few bill of materials, maybe. The assembly position list just tells you each position what assembly it belongs to. You have a total overview, and then maybe show a saw list. And this tells the shop which member to saw, how long, and which angle to saw it. So let's get back to BIM. So you see these walls, we didn't touch them. They're not steel, so we don't really do anything with it. But BricsCAD upgraded them to BIM. And usually what happens when we export IFC BIM export, we only do the steel, and we ignore everything else. And when BricsCAD exports, they don't know anything about our BIM data, and they ignore that. So BricsCAD made an API to export both, and we can add our BIM data to their BIM model, actually. And so if we export this together, we will open it in Solibri. It's an independent BIM viewer. And so you can see that our LOD 400 information was all added to the BricsCAD IFC file. And we skipped, for the parts where we have a LOD 400 counterpart, we skipped the LOD 200, and the ones that don't have a counterpart are just exported by BricsCAD. All right, so we spent on this IFC export maybe only a few weeks, because we already had an IFC implementation, of course, but it's not a difficult interface. I would certainly recommend other applications to do the same. And the BIM modeling, the 3D modeling that we did, also, the API for that didn't exist a few weeks ago, so that's also very easy to use. And if more applications do the same, we can have, like Eric says, a real BIM ecosystem on BricsCAD. And that would be unique, because Autodesk has all these verticals and they're separate and not integrated. This wouldn't be possible. So thank you, Bricsys and Eric, for BricsCAD and for these innovations. We are really excited to have you guys as partners. And thank you all for listening.
Thank you very much, Rudy and Jeff. I think this is quite inspiring, the kind of workflow we can offer to our users, combination of our BIM, or API, and applications like Parabuild. Just want to mention this, this API is available to everyone. It's included in our Bricsys SDK. And so I hope this will give some ideas to other developers, present the possibilities we can offer, unique workflows that we can offer to our users thanks to this solution. Thank you, everybody.
So I want to invite one more person up to the stage for a few minutes. This is Rob Kobani from Computers and Structures Incorporated in Walnut Creek, California, new to the Bricsys family. But these guys have been around since 1975, as you can imagine, being from Walnut Creek, which is the Bay Area where I come from. You have to be experts in seismic analysis. But these guys have been doing analysis since 1975. They've got some great tools. Again, new to the Bricsys family, but Rob wanted to take a few minutes to show us the types of things they're doing today and talk briefly about the integration that they have planned with BricsCAD. So, Rob? Oh, come on, take this one. You need to be there. Is there a mic that I can... Sure.
This will work fine. Perfect. Yeah, good. This works? Okay, thank you. My name again, Rob Kobani. So our part of this business is we're structural engineers. We develop analytical software. And the program that we're talking about today is Etabs. And we've written an exchange with Etabs into BricsCAD. And just like Parabuild, that exchange didn't exist just a few short weeks ago. So it was not difficult for us to create this exchange. I'm going to show you a couple different examples, but one of these, it's a pretty impressive project by SOM engineers and architects in San Francisco. This is a 320-meter tower. One of the things that we have heard complaints about from engineers is that oftentimes on some CAD systems, they don't scale well. So when we created the link into BricsCAD, one of the things that we were really pleased to see is that BricsCAD really scales wonderfully. So I'll show you here. Okay, this is the tower in Etabs. And so what is Etabs? Etabs, anybody here knows what Etabs stand for? TABS is the three-dimensional analysis of building structures, and E is an extended version. It's an old name developed in the early 1970s. But what it does is it's the analytical tool that's used to create an analytical model, and with that analytical model, we can expose a structure to seismic waves, wind loading, gravity loads. We even have a building in San Francisco which has settled a half a meter. Obviously, somebody, when they went through their gravity analysis, didn't consider quite everything. We still don't know exactly why that's moving, but nonetheless, an engineer would use a tool like Etabs to generate a structural model, and it's going to size all of the members. But we still need a program like Parabuild to come along and create the structural detailing. So the biggest hurdle that we have is once the analytical model is complete, and you can see we have a plan view up here. That plan view is not ready for a contractor to bid on. So the kind of steps that we would take, the kind of steps that we would take is we would move from Etabs into the program BricsCAD, and we have written an exchange. And if you open up your program, you will not see the CSI CrossCAD in it. That's an exchange that we've written, but this is the exchange that can be used to generate these kinds of three-dimensional, to bring in these three-dimensional models into BricsCAD. So my colleague wanted to remind me that these models, when they come in, are created using a number of XREFs. That's the way it's done. So I'm just going to walk through a couple of examples here because I just wanted to show you a couple of different examples. So here is the Etabs tower. This is 320 meters. And then when you hit that CrossCAD button, you'll see a menu like this. All you have to do is click on the Etabs file, and then it will populate all of these different floor plans. And then we have different sections that you can look at. These are all of the steel frame members. This is part of the core framing. These are the individual floor plans. Now, these are the structural drawings that an engineer would use as part of their construction set of documents. And these would then be part of that construction set for bid, for fabrication, for construction. So these are just moving up the tower. Here's an exploded view of reinforcing steel. The reinforcing steel is designed within the Etabs program, and then the reinforcement drawings in all their detail would come into BricsCAD like this. So these are elevations showing all the rebar. These are plan views showing different walls, different rebar configurations. I'm trying to keep this very quick. And then there are some other pretty notable structures. So, I mean, we were pretty amazed that an Etabs model with all this complexity scales very well into BricsCAD, and here it is. So we were amazed. We thought that was just quite good. This is a tower in Las Vegas, a hotel tower, and here it is in BricsCAD. Here's one of the floor plans. Another floor plan here. Okay, I think you get the idea. And then lastly, this was a building used for the Olympics in Beijing. So with that, try to keep us on schedule. Thank you very much.